Welcome back to The Explainer. Today, we are digging into something big, a story about a quiet revolution that's, well, shaking the very foundations of Silicon Valley.
So has AI just become too expensive? Let's dive into that for a second. It's a question that's been on a lot of people's minds, especially when you see these tech giants just burning through billions of dollars in this frantic race for AI dominance.
And that expensive arms race, it was literally driving everyone straight towards a wall. And we're not talking about just any wall here. This was something called the hard data wall. And trust me, colliding with it was about to change absolutely everything.
Right. So to really get what happened, to understand this revolution, we've got to first understand the crisis that caused it. And it was all built on this totally unsustainable strategy of just pure brute force.
So what is the hard data wall? Well, it's the point where the well of high-quality human-generated data, the stuff on the internet, was just drying up. The biggest players, we're talking OpenAI, Google, Meta, they were basically running out of fuel for their massive AI engines. The whole more data is better idea was seriously under threat.
And their strategy was, well, pretty simple. Just consume everything. Burn billions on GPUs, scrape every Wikipedia article, every GitHub repo, every Reddit archive you can find. The problem? They were starting to feed AI with other AI's synthetic data, risking this thing called model collapse. That's where the AI starts to get dumber because it's learning from itself, a potentially catastrophic problem.
Okay, so while all the giants were out there just desperately looking for more data, a small open-source team decided to look for a way to be smarter.
And they asked this one simple question. The Allen Institute for AI, or AI2, they just asked, can we extract deeper learning from the data we already have? And that single question, wow, it challenged the entire industry's direction. It was this huge pivot from just blind quantity to thoughtful quality.
And their answer to that question? It was a model called OLMO Hybrid, an open-source model that did something everyone thought was impossible. It matched the quality of its giant competitors using literally half the data.
So, you're probably wondering, how on earth did they do that? Well, it came down to this really brilliant two-part strategy, a kind of pincer attack.
Okay, part one, they completely re-engineered the AI's brain using a concept called mixture of experts, or MOE. Now, instead of one giant, overworked brain trying to do everything at once, think of it like a team of specialists. You've got your math expert, your language expert, your coding expert. You get the idea.
And this really shows you the difference, right? The old way, the dense model way, was like waking up the entire 100 billion parameter brain for every single problem. Super inefficient, super power hungry, but the OLMO way, it's smart. It's like, hey, you're asking a math question? Let's just activate the math expert. It's fast, it's efficient, and it's precise.
All right, so that was the clever architecture. The second part of the secret was what they called a cybernetic diet. They started with a massive data set, but then they deployed these supervisor AIs to scan and score every single document. They were ruthless. If it was low quality, if it was contradictory, boom, it was gone. They didn't just scrape the internet, they curated it into this highly refined golden data set.
And just look at these numbers. It's incredible. They went from a bloated 15 trillion tokens of raw data all the way down to a golden data set of just 7 trillion. They cut it by more than half. And this was the proof, right here, that quality has a way bigger impact than just sheer size. So, this new level of efficiency, yeah, it didn't just stay in a research lab. It sent a massive shockwave through the entire tech ecosystem. This is where things get really interesting. Think about it. Before OLMO, if you wanted to train a state-of-the-art model, you were looking at a bill of over $100 million. And that's just for renting the GPUs. It basically locked out everyone except for a handful of mega corporations.
But OLMO's equation was so simple, it was genius. Half the data means half the training time, which means, you guessed it, half the cost. They just completely dismantled that economic barrier. It was like democratizing AI development practically overnight.
And hey, the proof is in the pudding, right? Look at these benchmarks. This is the gauntlet. On things like MLMU for general knowledge, OLMO actually outscored bigger models. For Python code generation on human eval, it was right on par with the giants, but with fewer errors. Same for complex math problems. It went toe-to-toe with the Goliaths and won.
And a software victory this big? It immediately triggered a hardware revolution. All the big chip makers, Apple, Qualcomm, MediaTek, they all started racing to redesign their chips to support this mixture of experts architecture. The goal?
to get that server-grade AI running right there in your pocket without completely destroying your battery life.
But you know, the most profound impact here wasn't just technical or even economic. It was about something bigger. It was about who now holds the power.
See, the Allen Institute, AI2, they didn't just build a better mousetrap, they built a better one and then gave everyone the blueprints. They released everything open source, the model weights, the training code, the router structures, even the debugging logs and the prune datasets. This level of radical transparency, it was a total game changer.
And what that did was catalyze a full-on rebellion. Before OLMO, you needed these insane, expensive GPU clusters, and all the best AI was locked behind some corporate API. But after OLMO, a startup could build a competitive model on commercial hardware. We're talking about a dual RTX 4090 setup you could have in your office. The power was suddenly back with the developers.
And this led to a new reality. The era of just bragging about raw trillion parameter counts, well, it's dead. It marks a fundamental shift in how we even measure intelligence in these machines. Bigger is not always better anymore.
So the future isn't about blind quantity anymore. It's about engineered quality. It's about these adaptive architectures and something called agentic workflows, where the AI can actually make plans and use tools. We've officially moved past the age of brute force and into an era of elegance and efficiency.
So, the old AI empire is being dismantled. What are we all going to build with the pieces? OLMO proved that intelligence isn't about size, it's about the elegance of the algorithm. And that leaves all of us to wonder, what comes next, now that the keys to the kingdom are pretty much in everyone's hands?